Hello, welcome to the Backyard Machine Shop. Again. Well, guys, I've just spent the last 30 minutes putting this motor together, explaining in detail what I was doing, and I forgot to turn on the camera. So I'm not taking the motor back apart, but what I'll do is I'll go through and tell you what I've done. And so in the last video, we were in the process of pulling off the drive-in bearing, and it was hard. I couldn't get it off. None of the pullers I had would work. The splitters I had wouldn't work. I thought about welding on something to the outer race and pulling it off that way. So basically what I ended up doing is I ended up taking a Dremel tool and cutting the bearing, and then taking a chisel and popping the bearing open. Didn't take but 2 minutes. You know, I would have spent all kind of time trying to build something. 2 minutes there. Next thing, I took the cage, went through and cut through the cage and got the cage off. And then I took the Dremel tool back, and same thing. I took and just come in here and split it open a little bit, drove a chisel in it, popped right off. Well, after I'd done it, I see why it wouldn't come off. When they assembled it, I don't know if there was some clearance issues in this bearing or what, but it looks like it was glued on, or either, I don't know. I think it's glue, but I put a torch to it. I couldn't get it. You know, everything around it's aluminum, so you can't get it real hot. But anyway, I put a torch to it trying to get it off. That didn't work either, so that's why I ended up having to cut it off. But it was glued on, and I probably would have never popped it off. So, back to today. I purchased new bearings. We got a 6308 for the drive side, a 6306 for the back side, and basically the way I put the bearings on is slide. I mean, we could do it with a hydraulic press, but you'd have to set the press up, move it up and down, do a whole bunch of stuff. So the best way to do bearings is to find you a bushing or a pipe the same size as your race. Okay, so we have this brass bushing here, and then we have this piece of bronze. So basically, I slid the bearing on, it took a hammer and just knocked the bearing on. So, got that side done, and same thing for the other side. Got a piece of brass, this bronze here works perfect, taking this and drove it on. Bolted everything up. Everything's clean on the inside, and the motor's nice and free. I thought we was going to have trouble with these flanges. No, these flanges that are inside here, they didn't even need to go back in, but they're like a grease packing gland, and I didn't want to not put them back in case somebody somewhere down the road needs to rebuild this motor again in 50 years, and they want to use grease. So what I put in here is I put in a 6308 RS, which means it's got a rubber seal. It's a grease for life bearing. When it runs out of grease, you change it. Lasts maybe 15-20 years. In this end, we put a 6306 RS, same thing. Maintenance free, never have to mess with them again. And that's one of the things you can do with these motors, is a lot of these old motors were built back in the day where they didn't have the RS bearings and things like that. So, and you can grease them if you want to. Personally, I like to use the rubber seals where I can. The only thing the rubber seal does is you can't quite run as many RPMs as you can with a sealed bearing or shielded bearing. But this motor's 1750. It's nowhere near maxed out. I don't know what it is on the 6308. I can look it up, but it's nowhere near maxed out. So we're good with bearings there. So what we have here is I have the motor, and you can see the straps. I've got it bolted down. Now, this motor's going to run smooth enough that it doesn't need the straps. But, however, if there's something I did in there and got it out of balance, I don't want it to just roll all over the table. So I've strapped it down. I've got it wired up to a plug over here, and I'm going to have to go over and start the phase converter and flip on a breaker for it to run. But I wanted you to see it run and how smooth it's going to run, and also wanted to make sure it ran before I put it back in the lathe or in the mill. So if you hold on a minute, I'll go start it up. Alright guys, there you go. Man, that thing moves some air now. We'll let it run for a minute. We're going to check it for temperature and heat. But nice and smooth. Got a little bit of groaning noise. Maybe that's just, I know what it is. It's got the fan in there was balanced with some screws, and one of them was loose, and I didn't tighten it back up. I bet you that's what it is. It's either that or that flange is rubbing a little bit in there. But it's starting to quieten up now. That's it. I'm gonna let it run for a few minutes, and we're gonna check it for heat build up. Make sure everything's good. All right, I'll come back in a few minutes. Alright guys, you remember me saying that it had a little whine to it, didn't sound quite right? Well, drove me crazy, so I ended up having to fix it. Well, I could get to it, and it's what I said it was. I'll show you a picture. But inside the cooling fins here, there's some screws that were installed to balance out the cooling fins, and one of them was loose, and so it was just rattling around. So I was able to flip the motor upside down, get a screwdriver and a wrench in there, and tighten that screw up, and that fixed the problem. So we're going to start it back up. We're going to run it again, let it run for about 15 or 20 minutes, and see if it builds up any heat. Yes, he's purring like a kitten now. Remember I said it was moving a lot of air? Look at that. So if it's moving on that side, it's got to be sucking it in on this side. Anyway, the cooling fin blows a lot of air. We're going to let it run for a few minutes and check it out, make sure we don't have any heat in it. Alright guys, one of the things I'm going to do is I'm going to pull load readings on it. I had checked them before I changed the bearings, and they were running around 5 amps a leg. So we're going to see what it is. See what we got here. Alright, first leg, 4.3, 5 amps, 5 amps. So we got 4.48, 5, and 5. So it's that 4.4 is probably the high leg. So all right, it's been running about 4 or 5 minutes now, and we're at 59 degrees on that bearing. 58 degrees Fahrenheit on the motor itself. If you want to look at the table, the table is at 58 degrees, and Got front bearings at about 59 degrees. Shafts at about 59. Alright, we'll come back in a little bit. Alright guys, so we're going to shoot a beam right at that bearing. And we're at 64 degrees on the shaft. We're at 62 degrees. On the housing, we're at 63. We'll shoot one back here, 61 degrees. So, alright, let's do the same thing with the rear bearing. Okay, 60 degrees. The housing is about 59. And my table is 56. Okay, looks good so far. I don't think there's going to be a problem. Alright guys, let's see. Rear bearing 62 degrees. Housing 61. The case 63. Table 58. The front one here. $67 degrees. Shaft temperature 65. Case 67. And if you really want to know, the table is 59 degrees. Alright guys, well, my opinion, motor's in great shape, ready to go back in the machine, and don't think we'll ever have any more problems out of it. So let me go cut it off.